Welcome to the Explainer. Today we have a really fantastic journey ahead of us. Every single day it feels like there's a brand new AI buzzword popping up on our feeds. LLMs, tokens, context windows, prompts, agents. Honestly, it can feel like a completely foreign language. But our goal today is to demystify all of these complex concepts by stacking them together, one by one, almost like building blocks. We're going to start from the absolute foundational code and build our way all the way up to a fully autonomous AI assistant. Trust me, by the end of this explainer, your understanding of how modern AI actually works is going to be completely transformed.
Okay, let's dive right into this bottom-up journey. We'll start with the brain, which are LLMs, then move to the language, or tokens. After that, the memory, via context, the rules set by prompts, the hands through tools, and finally, the autonomous worker, known as agents. Let's get started.
Starting off with block number 1, the brain, understanding large language models.
So, when you're chatting with an AI, it feels like absolute magic, right? But underneath that hood, an LLM is actually surprisingly simple in its main objective. It's really just a massive, incredibly complex mathematical engine built on an architecture called the transformer, and it's playing a rapid-fire guessing game to predict what word comes next. It's essentially playing the world's most sophisticated game of text completion. It looks at what you wrote, crunches a ton of math, and asks itself, okay, based on all my training data, what is statistically the most likely word to follow?
And this brilliantly illustrates the exact step-by-step loop of how that happens. Let's say you ask it, how is Mark's explainer? The model takes that input, does its math, and predicts the word very. But crucially, it doesn't just stop there. It literally feeds very right back into the original sentence. So now the input is, how is Mark's explainer very? Then it predicts the next word, good. It just keeps doing this loop, one single piece at a time, until it generates a special hidden stop symbol that tells it, okay, the thought is complete. That is the fundamental engine right there.
Moving right along to our second block, the language, tokens and tokenizers.
Now, while LLMs process text, they don't actually read human letters like A, B, or C. They only understand numbers. So they need a translator, and that's where the tokenizer comes in. As humans, we look at a sentence and we see a flow of words and emotional meaning. But a tokenizer looks at our words and acts as a middleman, basically chopping those words into tiny, digestible numerical Lego bricks called tokens. Everything you type gets broken down into these tokens, mapped to specific numerical IDs, fed into that math engine we just talked about, and then the numbers are translated back into human words for us to read.
Now, what's really interesting about this slide is that you might assume one word equals exactly one token, right? Well, not exactly. For really common words like hello or going, yes, that's one token. But complex words, they get split into smaller puzzle pieces. The word helpful might be split into H and helpful. Programmer becomes program and mer. On average, think of one token as roughly 3/4 of an English word. These tokens are the absolute foundational unit of data that an AI processes.
All right, on to part 3, the memory. This is where we get into context windows and RAG. Yes, the LLM has a smart brain and it has a language, but that pure math engine, it actually has no natural memory of the past. Every single time you talk to it, it starts with a completely blank slate. So to fix this, the system behind the scenes is secretly resending your entire past conversation history with every new message you sent. This is called the context window. It's basically the AI's short-term memory scratchpad. And lately, these scratchpads have gotten absolutely massive. Modern models can hold around 1 million tokens at a time. To put that into perspective, that's big enough to hold an entire multi-part fantasy book series, all at once. But what if you've got a massive corporate database that completely dwarfs that million token limit? You definitely can't stuff everything into the context window. It would be painfully slow and just way too expensive. That is where RAG comes in, which stands for Retrieval Augmented Generation. Instead of forcing the AI to read the whole entire manual every single time, RAG is a clever search technique that quickly scans your database, pulls out just the 2 or 3 pages relevant to your specific question, and hands only those pages to the AI. It saves an immense amount of time and computing cost.
Let's look at part 4, the rules. Specifically, user prompts versus system prompts.
Okay, so our AI now has a brain, a language, and a memory. Next, it needs a personality and a set of overarching rules, which brings us to prompts. Now, there are actually 2 very different layers of prompts happening here. There's the user prompt. That's what you type into the chat box, like, what is 3 plus 5? It's the specific, immediate task. But behind the scenes, developers set a system prompt. Think of the system prompt as the AI's actor character sheet. It might say, "You are a patient math teacher. Never give direct answers, always guide." Without that system prompt, the AI would just bluntly say, 8. But with it, it adopts a persona and replies, "Well, if you have 3 apples and you find 5 more, how many do you have?" That system prompt completely governs how the AI behaves.
Moving to part 5, the hands. We'll be looking at tools and the MCP.
We are really building something powerful now. Yes, it's got memory and rules, making it a very smart chatbot. But right now, it is completely trapped in a digital box. If you ask it, "What's the weather like right now in London?" it can't tell you because it has no live connection to the outside world. It needs hands. We need to give it tools. Now, a tool is basically just a function, like a weather search API. But here's the secret. The AI doesn't actually click the buttons itself. When you ask for the London weather, the AI thinks, "I don't know the answer to this, but hey, I see a weather tool's available." It writes a text command requesting the tool. Then, the surrounding platform, the software wrapping the AI, reads that command, goes out, checks the weather, and hands the result back. Finally, the AI reads that result and uses its language skills to summarize it beautifully for you. So, the crucial point is exactly how we plug these tools in. In the old days, developers had to write custom code to connect a weather tool to OpenAI, then completely different code for Google, and different code again for Anthropic. It was honestly a nightmare. Enter MCP, the Model Context Protocol. Think of MCP as the universal USB-C cable for AI. It's a standard protocol that lets developers write a tool just once, and suddenly it can plug seamlessly into any modern AI model. It is a literal game changer for giving our AI hands. And finally, the peak of our journey, Part 6, the autonomous worker, agents and agent skills. Let's move to and see how this all builds together into something truly magical. What happens when you let the AI loop its tools entirely on its own? Let's say you tell an agent, "Hey, do I need an umbrella today? And if I do, find me a place to buy one." The agent acts like a wildly efficient independent manager. It thinks, "Okay, first I need to know where the user is," so it uses a location tool. Then it thinks, "Now I need the weather for that specific location," and uses the weather tool. It sees it's raining, so it realizes, "Okay, now I need to use the shop search tool to find a nearby store." It chains all of these steps together completely autonomously until the whole complex job is done.
But, to make this truly useful for your daily life, you don't want to have to constantly remind the agent of your personal quirks, like the fact that you always want a quick summary first, or that you always carry a backpack. And that is exactly where agent skills come in. An agent skill is really just a predefined instruction manual, usually a simple markdown document you save once. It tells the agent exactly how you like things done, what formats you prefer, and what steps to take. It saves you from retyping your preferences every single time you need help.
So think about the incredible evolution we just built here. We've taken a mathematical text prediction engine, chopped up its language, gave it a massive short-term memory, handed it a set of firm rules, plugged it into the real world with universal tools, and then let it loop autonomously as an agent. If giving an AI memory, tools, and personalized rulebooks transforms it from a simple chatbot into a fully autonomous worker, what jobs will you delegate to your digital assistant tomorrow? Really think about it. Thank you so much for joining me on this explainer, and I will see you next time.